Welcome to this video on data types. Let's begin. By the end of this video, you will be able to define the term data, define the term variables, state which data type is a count, state which data type is a measure, state which data type is a label, and identify variables as either qualitative or continuous, quantitative discrete, or quantitative continuous. To start, let's talk about what is data. Simply put, data are observations. So let's imagine we're looking out over a huge car park or a parking lot. We could look at the cars and we could count the number of cars that are red. That's an observation. We could also observe the make of the cars. For example, are they manufactured in the United States or are they imported from another country? Any set of data is going to contain information about some group of individuals or things. In our example, the things that we're collecting information on are cars. We generally organize this information into variables. So for example, the color of our cars, red or white or silver, that would be a variable. Another variable could be the make of the car. A variable is a characteristic of an individual or thing. So, for example, color is a characteristic of a car. The company that manufactures it is another characteristic of that car. So let's get into data types. All data serves one of three functions. It could be a label, it could be a count, or it could be a measure. If data is serving as a label, we call that categorical or qualitative. Different textbooks will use one or the other term. If you're taking me as an instructor, both are acceptable. I don't care which of those words you use to describe your data. Data might be a count of something, and if that's the case, we call that quantitative discrete. Lastly, data might be a measurement, and this is called quantitative continuous. So sometimes when people are explaining these different data types, they will first divide these categories into categorical or qualitative and then quantitative data. And then they will further divide quantitative data into discrete and continuous, counts and measures. So if you have an instructor who's explaining it this way, that is also a valid way to understand it. So let's look at what these really mean. Again, we said that categorical or qualitative data are usually words, not numbers, but again, there are some important exceptions. Sometimes numbers act as labels. Okay, and again, if there are numbers, if the categorical data are numbers, that means that performing statistical analysis on them would be meaningless because the number is a label. So as you can see, I have a blank here for the examples because I stole this from my guided notes. So I'll just tell you some of the examples would be like your social security number, maybe numbers on a license plate. A phone number is a label. If I took my 10 best friends' phone numbers and I averaged them together, that would not be meaningful. Okay, so again, many times numbers can act as labels. Let's move on to quantitative discrete. As you can see, this is the counts. So we are limited in the number of decimal places they can have. So the two important examples are counting numbers. So for example, if I'm counting the number of people or the number of students, let's say in my class, I can't have 10.5 people. Now I could have one person who just attends half of the class, but I can't have half a person. That doesn't make sense. The other example is money. It's true that in a spreadsheet, you can have as many decimal places as you want to, but if I'm actually going to pay you in cash, I can't give you an amount of money that is smaller than 1 cent. I can give you $1 or I can give you $1.01. I can't give you anything in between that. Lastly, we have quantitative continuous, which are measures. Okay, they are unlimited in the number of digits they can have after the decimal place. Okay, in fact, that's limited only by the precision of the device you are using to measure whatever you're measuring. So the way I think about it is almost like a lab that you might see in physics or chemistry, right? So if you have to take a lab science, you might have to measure time, temperature, length, volume, area, weight, pressure. All of those things are measurements. Another way to understand the difference between quantitative discrete and quantitative continuous is to think of a number line. So one example is money. So as I mentioned before, a value in between a single cent is not meaningful. So if I were to use a number line to represent monetary values, it would look like this. And then there would be gaps. Again, so in between $1.16 and $1.17, I don't have any physical way to give you an amount of money that's in between those two values. So one characteristic of quantitative discrete data is that if you plot it on a number line, that number line is going to have blank spaces or gaps. Another example is if you're counting people, right? You can't have half of a person. So a number line for counting people would look like this. And again, there would be gaps in between your whole numbers that are not meaningful. The example of height of a tree, so think about height. Height is a measurement. So anytime you're measuring something, you will not have gaps in your number line. It would look more like this, where you have this smooth, continuous line, and you could literally plot any number you wanted to. Because again, if I'm measuring the height of something, the precision of that measurement is limited only by whatever device I'm using to measure it. So let's take a minute and practice identifying data types. I would strongly recommend that you pause this video at intervals and try to identify these data types yourself before you listen to my answer. First one. So let's imagine that we are at a baseball game and we are watching the game from the stands. So if I were to count the number of fans in the stadium, would that be a label, a count, or a measure? In other words, would that be categorical or qualitative? Would it be quantitative discrete? Or would it be quantitative continuous? So pause the video and say your answer out loud or jot it down. If you said it was quantitative discrete, that is correct. Again, we can't have half a person. That doesn't make sense. Next one, the name of the teams who are playing each other in the game. So pause the game, write down your answer. Okay, and if you said categorical or qualitative, you were correct. How about the cost of the concession snacks that are for sale? Is that a label, a count, or a measure? Okay, it is a count, which means that it is quantitative discrete. How about the length of time of the game? Is that a label, a count, or a measure? Okay, it is a measure, so it is quantitative continuous. How about the numbers on the back of the players' jerseys? Is that a label, a count, or a measure? If you said that it was a label, that is correct. How about the outside temperature? Is that a label, a count, or a measure? It's a measure, so that means it's quantitative continuous. How about the score at any point in the game? That is quantitative discrete, and that's simply because if you know anything about baseball, you can only have a whole number of runs. You can't have 1.5 runs. Now, of course, in the middle of the game, you might have people on bases, but anytime you look at the scoreboard, you're only going to see whole numbers.